Hi, my name is Naina Tallak, and I'm presenting from Saratoga, California, and I'm evaluating carbon sequestration techniques to mitigate climate change. My mentor was Joe Macheski, and I picked this topic because I've witnessed firsthand the effects of climate change and global warming, both in America as well as in other countries like India, where pollution has really taken a toll on the quality of life for citizens. So I picked this topic because I wanted to figure out solutions for this prevalent issue. And I chose to focus on carbon capture methods and biochemical ways we can help mitigate the climate crisis because relying on humans only will require a longer timeline, which we can't afford. And this is to meet goals set by the Paris Agreement in 2015, which was to limit global temperature by about 2 degrees Celsius by 2050. And that requires capturing about 10 gigatons of carbon per year. And I evaluated 7 techniques. Most of these deal with the ocean in some way, either enhancing it or taking place in the ocean, except for cover crops. Cover crops involves enhancing the soil's ability to capture carbon by planting specific plants like wheat, radish, or rye. Then RDOC involves recalcitrant dissolved organic carbon, which converts organic carbon to bicarbonate to increase ocean alkalinity. Limestone involves magnesium and calcium occurring already in the seawater to react with carbon dioxide to form limestone. Ocean alkalinity enhancement is what it sounds like. It's adding alkaline metals to the ocean to fight against ocean acidification and then allow the ocean to capture more carbon. Macroalgae can absorb carbon and then be transported to the deep ocean where it will sink for long-term storage. Seaweed cultivation is similar as seaweed will capture the carbon and then be transported to the deep ocean for storage. Ocean fertilization involves adding limiting nutrients like iron to the ocean, which will then stimulate phytoplankton growth and produce organic matter. And this organic matter will then absorb carbon and then similarly be transported to the deep ocean for long term storage. And I evaluated these techniques on 5 variables. First, I did expense, storage capacity, and potential environmental risk. And then I narrowed it down to 5 techniques and I evaluated those on their scalability and their location, so what kinds of environments they will require. Then these are some of the results that I found in my research. I found the expenses and the storage capacity for each of the techniques. As you can see for storage, the numbers are pretty low. As I said, that we do need about 10 gigatons of carbon captured per year to meet the Paris Agreement. So we will need a combination of these techniques to make a significant impact. And this can be visualized in this graphic here. The size of the bubbles represents the environmental risk they pose. So from this graphic, we can see that RDOC is the most promising technique as it has relatively low expense, high storage capacity, and a medium environmental risk that does need further research on to be confirmed. And here are some more visuals. So on the left are the seaweed farms globally. So this would help visualize where seaweed cultivation may take place. On the right are the ocean depth zones. So in the light blue areas, that's the surface waters. So that would be where seaweed cultivation, ocean fertilization, and ocean alkalinity enhancement would take place. And then the dark blue areas are the deep ocean. That would be where techniques like RDOC would take place. And so from my research, I found that cover crops, RDOC, and seaweed cultivation are the most promising techniques. Cover crops and seaweed cultivation do have an economic benefit as well as environmental benefit, but they do have low storage capacity, so a combination of these techniques is definitely required. RDOC has a significantly large storage capacity, but the potential environmental risk needs to be further researched on to confirm that it will not harm the environment significantly. Further research is also needed on cover crops, as we've only done short-term experiments, so we do need long-term experiments with this. And then seaweed cultivation, we do need more technology for large-scale transportation of this seaweed into the deep ocean for storage. Then once this research has been done and confirmed that these techniques are truly promising enough, we can then implement all of these techniques to make a significant impact in mitigating climate change. Thank you for listening.